Hey guys, welcome to Easy Academy. Today we're going to be learning about different types of sampling designs. So the first type of sampling design is the simple random sample, or SRS. So in the simple random sample, you're quite simply just taking an individual randomly from a population as many times as you want to get your sample size. So for example, if there's a population of 100 people, your simple random sample would be just generating number from 1 through 100 and getting 5 of them if your sample size is 5, and that would be your simple random sample. Of course, it's notable that you have to have no repeats in a simple random sample, so you have to generate different numbers each time. And some of the advantages of the simple random sample is that one, it's unbiased because you're just generating a number from 1 through 100, and second, it's easy to use because, of course, you're just generating a number. So, however, one of the largest disadvantages of the simple random sample is the large variance, insofar as there can be many different possibilities to what your simple random sample is every time, insofar as you're generating a random number each time, so the amount of possibilities that comes out of the simple random sample varies a lot. So it may not be as representative as some other sampling designs. But second of all, you have to have a sampling frame in order to conduct this sampling design. The sampling frame is essentially the population that you're sampling from. So for example, if you have the population of 100 people, that would be your sampling frame. The reason why this is a disadvantage is because some populations are very, very large. For example, the population of everyone in the United States of America, it's over 300 million people, which means that it'd be very hard to conduct a simple random sample insofar as the population size is just so big. Alright, so the second type of sampling design is the stratified random sample. So in the stratified random sample, you divide your population to different groups. So for example, if you want your population to be high schoolers and you want to divide into 4 different categories, let's say you have the freshmen, the sophomores, the juniors, and the seniors, you divide them into 4 different categories. So like the freshmen are here, the sophomores are here, juniors are here, and the seniors are here. And essentially, you'd be taking a simple random sample within each division. So each division is called a strata, which is why it's called the stratified random sample. So you would be taking a simple random sample of, for example, 2 people from each strata, and you essentially have that as your stratified random sample. So one of the advantages of the stratified random sample is that it's more precise and unbiased than the simple random sample. Obviously, if you split up all of the population into different groups and you random sample from each group, it means that each group has representation, which means that it's more precise and there's less variability. However, one of the biggest disadvantages of the stratified random sample is that it's very difficult to do if you must divide into stratums. Sometimes the population can make it very difficult for you to divide things into different groups, and it's very arbitrary. And second of all, the formulas for standard deviation and confidence intervals for stratified random samples are more complicated simply because you're not just randomly generating a number from like 1 through 100. You're actually dividing it up into 4 different subjective groups. So the standard deviation and confidence intervals don't work out the same way. So the third type of sampling design is the systematic random sample. The systematic random sample is similar to the simple random sample in that you randomly generate a number. So let's say we have 10 people here and we randomly generate a number and we want a sample size of 3. So if we randomly generate the 4th person here, the 4th person here in similar fashion is generated by a random number generator, but becomes the starting point for the rest of our sample. So our sample size is 3, so our sample becomes the 4th person, the 5th person, the 6th person. So in this vein, it's similar to the simple random sample, but not exactly, because the first person generated becomes the starting point for the rest of the sample, while in the simple random sample, you constantly generate new numbers. So one of the advantages of the systematic random sample is that it's unbiased and you don't need a sampling frame insofar as your starting point may not necessitate that you have an entire list of the population. But second of all, you can ensure that the sample is spread across the population because you're selecting people right next to each other, and you can ensure that you get some form of the population in there. Also, it's more efficient and cheaper insofar as you don't need the sampling frame and you won't need exhaustive lists of people in order to conduct your sample. One of the biggest disadvantages is because there's larger variance from the systematic random sample, simply because if your starting point can be way off from another starting point of another systematic random sample, you could start at 1 here, and in another systematic random sample, you start at 8, for example, and that there's a very large variance in with the systematic random sample. It can also be affected by trends or cycles. It's vulnerable to this type of thing because people who maybe align closely with each other can have similar tastes in whatever you're trying to sample, so it could be affected by larger trends or cycles. The fourth type of sampling design is cluster sampling. In cluster sampling, for example, if your population is the population of the United States, you can use cluster sampling by separating everyone to different groups, for example, in different cities. So if you have some people from Arizona, some people from California, some people from Massachusetts, and so on for the rest of the 50 states, you select one of these cities to have your sample. So one example could be if you randomly select one of these cities and suddenly becomes Arizona, you pick Arizona and you sample, for example, 10 people from Arizona for your sample. And one of the advantages of the cluster sample is that it's unbiased because you're randomly generating which city you want to take your sample from. But also the cost is reduced because you no longer have to sample everyone from the United States, or for example, like a minimum amount of people, like 10 people from each state, which can be pretty costly. And you also don't need a sampling frame here because you're only sampling people from one cluster of your entire cluster sample. But one of the biggest disadvantages is that cluster sampling may not be representative of the population. So if your population is the United States and you only take people from Arizona, that could lead to some biases that show in your sample, which is not very representative of the entire population, and people from Massachusetts and California could be left out.